This is, we're going to switch topics from geology to paleontology. I live in dinosaur country in Bozeman, Montana. This is where Montana State University is, in the Museum of the Rockies. And this is where they've done a lot of research on dinosaurs, where they found dinosaur eggs. And this is where they've discovered the soft tissues in dinosaurs. It was all done in the same city, so I just couldn't help but get involved in this. So now this talk is going to be about dinosaur challenges and mysteries. I'm going to briefly mention challenges for the evolutionists, but I mainly want to answer challenges to our paradigm. See, this is mainly what I've been doing for 40 years, to try to answer challenges. So this is what this talk will be about. And the main challenge, of course, is how do you account for dinosaur tracks, eggs, and bone beds. Let's see if this... I can't advance this. I need a computer person to give me a hand. I'm computer challenged. That's my challenge. And when I get these smartphones, I realize I'm phone challenged also. In trying to answer questions from the culture, I've run into, in 40 years of research in the earth sciences, probably a few hundred challenges. And I've been trying to answer these. Some of these I've worked on and some I haven't. But this is a list I just did for 5 minutes. I'm not going to go into any of these in details. But these are challenges we need to answer. And so the last one, Dinosaur Tracks, Eggs, and Bone Beds, is the one I'm going to be dealing with in this talk. Here's the challenge, one of the challenges. This is a quote from Glenn Morton on his website. I picked it up in 2004. It's features like these: termite nests, dinosaur tracks, cicada burrows, and channels are not easily explained by the YECs, Young Earth Creationists. They don't show their followers this type of data, and they have not explained it. That's rather interesting, because I started to dealing with a hypothesis on this issue of dinosaur tracks in 1996 in the creationist literature. So I don't think Glenn Morton is acquainted with the creationist literature when he made a statement like this. Also, this issue of tracks has caused a lot of people to think that, oh, they can't be explained, therefore we need to add millions of years and it can't be explained by the flood. For instance, this is a quote from Science. This is explaining how a man went from being a young earth creationist to I don't know what, but he lost his faith in the Bible. Mostly so. I don't know the whole story, but anyway, this is reported in Science magazine. It was because of tracks. You can see the quote there. It says, "By day, coring through thin layers of rock, we started to come across footprints by terrestrial animals," says Godfrey. "You can't imagine a global flood of animals finding ground to make footprints on. That, more than anything, and any other experience in my life, really shook me to the core." So that's the finding of tracks that really caused them to doubt the Bible. I believe there's more to this story, because as I read, I realized that he wasn't really taught much about geology and how there's so much evidence for the flood in there from reading some of his statements. So there's a lot more to this. He wasn't taught it. That's why we need to learn this issue, teach it to our children and grandchildren, because there's too many of these things that come up in the university that challenge our faith. Before I get into the answering or providing a reasonable solution to our challenges, I want to speak very briefly on a few evolutionary challenges. When you read about dinosaurs in evolutionary literature, sometimes you get the idea that they have all the answers. So that's why you have to dig down below the superficial level and see that, hey, they have their problems too. In fact, when I examine a challenge to us, I find out the first thing I discover is that it's a challenge to them also. A lot of times you wouldn't know it because they paper over their challenges with other hypotheses. But they're challenged by some of these issues too. So we'll talk about polar dinosaurs, desert dinosaurs, dinosaur soft tissues, and the extinction of dinosaurs. Here's a little plot, and I'm realizing that it's not done well. I should have these in different colors, but these are dinosaur tracks and dinosaur fossils, bones found at high latitudes in the northern hemisphere. You can't see it. There's a track on Spitsbergen. And see, there's a track. By the way, this is not complete. And there's a dinosaur fossils found in Greenland and Alaska, Siberia. I've since found out that there's one in northern Norway. There was dinosaur fossils were found. Mats Malin of Sweden told me about that. And there's a track right in there that's not plotted. So, in other words, you got a lot of dinosaur evidence live at high latitudes. How do they explain that? Now, if you go to the southern hemisphere, and assuming plate tectonics in this case, plate tectonics didn't really affect the northern hemisphere very much for this dinosaur period, but I just assumed it here just for sake of discussion. This would be the 60-degree south latitude circle here. Southeast Australia has a lot of dinosaurs, which would be at high latitudes, and then New Zealand has dinosaurs in Chatham Islands. But if you don't believe in plate tectonics, regardless, you still have dinosaurs found in Antarctica in two places, in the Antarctic Peninsula and right in here. So we have dinosaurs on Antarctica. So how are they to be explained? Well, they don't really know. They used to think of dinosaurs living in steaming swamps. So this is a kind of a paradigm shift for the secular geologist. For instance, Michael Benton says in the journal Trends in Ecology and Evolution, should we now imagine dinosaurs as thermally insulated warm-blooded animals that plowed through snowdrifts and scraped the ice off the ground to find food? So he's perplexed. Another guy says, even if polar dinosaurs were able to subsist on poor quality food for some time, that's during the nighttime, the wintertime at high latitudes, a photosynthetic crisis of some duration would have been fatal to them because even this food resource would have become exhausted. In other words, they'd have problems finding something to eat at high latitudes. So this is a big problem for them right now. And then desert dinosaurs. I put desert in quotes because I have found, and other creation scientists have found, lots of evidence that these sandstones that they find these dinosaur tracks in are not desert sands. Anyway, here's a quote from Martin Lockley, the top expert on dinosaur tracks in the U.S. He says, the tracks occur at the top of the Middle Jurassic Entrada Formation. The main body of this formation represents an ancient sand sea of the type associated with the Sahara Desert. And they find hundreds of thousands of these dinosaur tracks in these sandstones in the western United States that they think are from sands like you find in the desert. And these are mostly carnivorous dinosaur tracks. So the question is, what are carnivorous dinosaurs doing living in a desert? What are they going to eat out there? So these are major challenge. This is another major challenge to the evolutionary paradigm on dinosaurs. And then soft tissues. This is the upper part of what's called the Wankel T-Rex on display at the Museum of the Rockies in Bozeman, Montana, where I live. Now, it actually isn't there at the moment. It's actually a traveling exhibit, and so I don't know where it's at. It's somewhere in the world now. But this is mostly bones. This thing isn't even fossilized, and this is where they find the soft tissue. In fact, there's a kiosk right there where you can read all about it. The Wankel T-Rex found in the Hill Creek Formation, and you find this. You find blood vessels and cell-like structures in it. Dr. Mary Schweitzer was originally did this research at Montana State University, and so you can see it right there about all this. And of course, they don't admit that these are red blood cells, but they sure have all the appearance and in the right position to be red blood cells. Now, red blood cells decay really rapidly, so this is a major problem for them to explain, because they think these dinosaurs are around 68 million years old. So how can red blood cells and flexible objects, you can stretch these objects, last for millions of years? That's the big problem. That's the challenge. It's a challenge to their time scale. For instance, Mary Schweitzer and others said in the proceedings of the National Academy of Sciences, traditionally there was little hope that biomolecules might be recovered from bone more than a few thousand years old. I mean, I think they're right. In fact, I think we have a bit of a problem explaining it in the flood about 4,500, 5,000 years ago. So, but millions of years ago, in fact, it was such a shock that Mary Schweitzer said it was totally shocking. I didn't believe it, that is the finding of likely red blood cells, until we'd done it 17 times from science. So this is a major problem, and a number of creationists have written on this, including myself. Then the question is, how did they go extinct? And as Glenn Jepson says in American Scientist, by far the most baffling major question about dinosaurs is what caused their extinction. And of course there's lots of reasons that have been suggested, over 100 reasons, which gives us an idea that there's major problems. Brains were too small, like the brain of a stegosaurus is the size of a walnut. You've probably heard that before. They couldn't compete with the mammals. Other animals ate their eggs. Disease or glandular disorder, chronic constipation. This one is a serious hypothesis, because if the food evolved, it's possible they can eat the food and not be able to digest it. So it is a serious idea. By the way, meteorite impacts down there at the bottom was considered a long shot before 1980, until they developed the meteorite extinction hypothesis that's popular right now. But here's a little cartoon about this. The picture's pretty bleak, gentlemen. The world's climates are changing, the mammals are taking over, and we all have the brain about the size of a walnut. Oh, big problem. This is the real reason why I think dinosaurs went extinct, right here. So, young people, don't take up that nasty habit. Anyway, here's a quote from a guy named Frank de Courton in Dinosaurs of Utah, indicating that it's still a mystery regardless of the meteorite extinction hypothesis. Each can find at least some support in the geological and paleontological data that can be brought to bear on the issue. But the fact of the matter is that even now, at the end of the 20th century, there is no single explanation for the demise of the dinosaurs that is universally accepted by even a simple majority of scientists. So it's still an unknown why they go extinct. I think the flood could be a reason, except for those that were on the ark. I'm not going to get into this issue. But I'm going to get into the issue. What is the challenging data that we need to explain? Well, the really challenging data is dinosaur tracks. You find them now by the billions across the earth. Here's one in northeast Wyoming. And here's one that's about this wide of a duck-billed dinosaur type that was really huge. This is found from a coal seam at the top of a mine in Utah. So this is an issue of how come you find dinosaur tracks on the roofs of coal mines at the top of the coal. I believe there's an answer, and it can be answered, and I've actually have a reasonable solution to that, but I don't have time to go into it. But here is a plot, 1,500 dinosaur track locations. This is old. They're finding new ones every year, so you can see that they're worldwide. You find them all over the earth, even in Spitsbergen up there, northern Alaska. So lots of them in the western United States. On the high plains and the Rocky Mountains, there's millions of them there. You also have these dinosaur eggs. It's really interesting that before 1980, they hardly found any dinosaur eggs or dinosaur tracks in the rocks. But once they started finding them, they're now finding them all over the place, like the tracks. They find them by the billions. Dinosaur eggs now by the millions are found across the earth. And here's a plot that's old. This is an old plot of dinosaur eggs. And you can see they're found in many places in the earth. Lots of them in Mongolia and China, along the Pyrenees Mountains in Europe, even in southern England. Lots of them in the Rocky Mountains and the High Plains. A fair amount of them in South America. And they're finding more and more all the time. And we find that when we look at dinosaur bones or bone beds, we find evidence of scavenging of dead dinosaurs. For instance, here's a dinosaur bone with teeth marks on it, right there. And we find the teeth of carnivorous dinosaurs like T-Rex here in the bone bed, but only the teeth that are broken off while he was scavenging, their teeth commonly get broken off. And when you don't find the rest of the skeleton, you realize that the bone bed was scavenged. So the bones laid there for a while, being scavenged. So the big question is, how can this happen in the flood? And this has been the challenge. So this is the verse I offer for this challenge. Like other challenge, I hold fast to that which is good, and then I'm going to examine everything carefully. That's what you have to do. You got to go beyond the superficial level, the popular level. And a lot of times you will see the problems that they have. And a lot of times when I do this, sometimes I do find a reasonable solution to these challenges within our paradigm. So there's three biblical options. They can be post-flood, they can be pre-flood, or early flood. That is before day 150. Why early flood? Because as the flood peaked at about day 150, everything's flooded, so you wouldn't expect any air-breathing land animal to live past that, even though I suppose it could happen. But you'd expect animals that lived on land, breathed the air. Those are the animals that went into the ark by twos. You'd expect those animals to be dead by day 150, and I would think well before day 150, as I hopefully will not forget to mention why. So this is my evidence that the early flood, I find neither the post-flood nor the pre-flood options make any sense when looking at the sedimentary rocks. First off, these tracks, eggs, and bone beds, and some of these bone beds have thousands of dinosaurs in them. They're on top of thousands of feet or thousands of meters of sedimentary rock already laid down in the flood. So they couldn't be pre-flood. Also, you have evidence that thousands of feet of sedimentary rock were eroded above that point, down to where you see the dinosaurs, indicating that it couldn't be post-flood either. So the only option I find is that it is early flood. For instance, I showed this slide the previous talk. Here's the current continental surface where you find the dinosaur fossils near the surface. And they're on thick sedimentary rocks, commonly found on thick sedimentary rocks. And then you can find evidence of erosion amounting to hundreds, sometimes thousands of meters, eroding down to this level, indicating that this was early flood, and this is from the retreating stage, making these early flood fossils. And I showed you evidence that of the erosion on the continents, and I'll just briefly mention a few highlights of that. The Colorado Plateau, you find millions of dinosaurs on here, on the Colorado Plateau, and it's been eroded tremendously. Like I said, 2,500 to 5,000 meters average erosion, down to the level where we see the dinosaurs. So that 2,500 to 5,000 meters was eroded late in the flood. So that's what is left is from the early part of the flood. And of course, I showed you this earlier. The erosion, this is an example of the erosion in the northwest Colorado Plateau of up to 5,100 meters. So massive erosion. So they're early in the flood. Oh, here's the quick statistics of erosion elsewhere in the world. This is just from the literature. By the way, I can get many more estimates like this. This is just a quickie for various places of the world. So, When I examine everything carefully, this is what I did with the dinosaur tracks, eggs, and bone beds. Let's gather the data first. Before we figure out or try to hypothesize an idea, let's get the data down. And so the first thing I do in a problem, I do a data search before generating a hypothesis. Sometimes this can take a long time. And in some problems, we may never get enough data to have an answer because there's many unknowns in earth sciences. So we shouldn't expect to answer every question. So, but we need to gather what we can. So in this case, I gathered and I've discovered a number of unusual features with bone beds or dinosaur graveyards, tracks, and eggs. The first thing I noticed is that there are numerous dinosaur graveyards, but which some are really huge, like west of, in Montana, west of Great Falls, Montana, where I used to live. There's a dinosaur graveyard of 10,000 dinosaurs, all the same species. They're duck-billed dinosaurs. In Canada, there's a Ceratopian graveyard of like Triceratops-like dinosaurs, but not Triceratops. There's various Ceratopians with different horns and head frills. Anyway, there's supposed to be over 10,000 of them there, and in China there's supposed to be one even larger. So some of these bone beds are monstrous, which when we see bone beds like this, you wonder, well, can present processes account for this? So, you know, this seems like more of a catastrophe than present day floods and things like this. They're commonly described as being buried in a flood. This is a common description of them, buried, and it's usually a monstrous flood. Often the bones are just jumbled together in a big mass, indicating a huge catastrophe. And the bones are little weathered, even though some of them are known to have laid out there and been scavenged by dinosaurs. There's little weathering showing up on the bones, meaning that they were buried fairly rapidly. Kind of what we expect in the flood, and not dinosaurs just laying there dead and being scavenged. And many of the bone beds contain just one type of dinosaur. Like those 10,000 in Montana, they're all of one type of duck-billed dinosaur, which is a major mystery. Why do you get just one type just buried all in a big mass in one spot? That's, you know, what's going on? Maybe they were herding together because of some catastrophe, and the catastrophe overwhelmed them. That's starting to suggest some possibilities. Also, another major unusual feature is the bones of babies and young juveniles are rare. When you see these bone beds, you only see older juveniles than adults. Now, modern day death sites show a lot of young animals that die in the catastrophe. So what's with the lack of babies and young juveniles? Well, is it possible that the babies and young juveniles could not flee this catastrophe and they were overwhelmed and pulverized by this catastrophe while the adults were able to flee for a while before they died? It's starting to suggest a possibility, which I will let you think about that until I get towards the end. Here's an example of a dinosaur graveyard. This is in New Mexico, Coliphus dinosaurs. They're all in a big jumble. There's over 1,000 of these dinosaurs. A Coliphus is about this size. It's very similar to a Velociraptor. And you know, this is just one example. Oops, that shouldn't be there. With dinosaur tracks, I discovered a number of unusual features. First of all, tracks of likely poor swimmers are rare. You know, there's a lack of tracks from Ceratopians like Triceratops, Ankylosaurus, and Stegosaurus, which you can imagine because of the big bony plates, head armor, stuff like that, they'd be poor swimmers. There's a lack of these tracks. Is it possible that many of these animals got overwhelmed early in the flood and so couldn't make tracks? Practically all the tracks are from adults and older juveniles, similar to the bone beds. Where are the tracks of the young dinosaurs? When you look at track layers made around today by elephants in Africa, you find just as many young and baby elephants as you do older elephants. So why is there a lack of them? here. Could it be that the young were unable to flee the catastrophe at the beginning, and the older ones were able to flee for a while until they died? Starting to sound more like a catastrophe. Then this is really interesting. Practically all the tracks are straight. Now, trackways. Now, a trackway is 2 or more tracks from the same dinosaur. That's the definition of a trackway. But they're practically all of them are straight. They hardly weave like that. Now, I'm a hunter, and I hunt deer and elk in the snow in Montana. And when I'm hunting them, they're going all over the place when I'm following them. But if I spook them, they run practically in a straight line away from me. And that's when they made straight tracks. Is it possible the reason that so many dinosaur trackways are straight is because they were fleeing a catastrophe? Another item, tracks practically are always on a single flat surface, flat bedding plane. You'd never see them, or rarely see them, climbing up to other bedding planes or like climbing hills as if there were no hills. It was totally flat where they lived. That's rather unusual, because if you let dinosaurs go today, they're going to be going all over the terrain, climbing hills. Then another interesting thing I found with tracks, you have sometimes several layers of tracks in the sedimentary rocks, like a layer down here, then a layer maybe 30 meters thick of sedimentary rock, and then another layer of dinosaur tracks. Sometimes you find the same type of dinosaur tracks on one layer as the layer above it. Well, the problem with this is that the secular scientists give hundreds of thousands to millions of years to these layers. And so these tracks could be separated by, say, 2 or 3 million years. Then, what is the odds of the same type of tracks being made in the same location 2 to 3 million years later? See, that's another problem. And what this does indicate is rapid deposition, and then these same dinosaurs maybe got moved off of this area, and then they came back over the area and made tracks in the same location. Here is a kiosk at near Shell, Wyoming, where they have a display of dinosaur tracks out in this bedding plane. Now, I didn't have a camera that can do a panorama, so I can't show the tracks out on here. But here they are. They're generally pretty straight. This is a plot of them. And by the way, in this strata above them, there's tens of thousands of oyster fossils just all through there. In other words, before they found these dinosaur tracks, they considered this a marine formation. And it still is, but suddenly you have a beach there with the dinosaur tracks. Anyway, there's millions of dinosaur tracks found there now. Also, just like with tracks and bone beds, I found a number of unusual features with the eggs. First of all, there's very few nest structures. Now, you might have read, some of who have read a lot on this might have seen references to nests, but nests can be defined. Now, John Horner of Montana State University defines a nest as just any eggshells. If he finds eggshells, that's a nest. But a nest structure is kind of a bowl-shaped feature, and these you don't hardly find any of them. Now, a researcher, Louis Chiappi, in 2004 reported in the journal Paleos that he found a bunch more in South America, and he admitted there's very few of these nest structures across the earth, but he was adding to them. Unfortunately, about 2 years ago, it was claimed that these bowl-shaped features were actually the eroded remains of dinosaur tracks, so they weren't nests at all. But the point is there's very few nests, and I will expand on this a little more. Eggs are essentially laid on flat bedding planes. There's little or no vegetation to cover them up associated with these eggs. And the problem with all this is that they found that the dinosaur eggs are quite porous. So with time, on a flat bedding plate, the embryo would dry out. So just like with a lot of reptiles, it should be either in a bowl shape or vegetation on it, or both. And you don't find these features. They're on flat bedding planes, which is rather unusual for those porous eggs. It gives the impression that these dinosaurs were in a hurry. They had to shed their eggs, and so they just shed them on the bedding planes and took off. So that's what the majority of these egg finds are showing. So it's appearing that the features are not from a normal environment, but from a catastrophe. Here's a picture of one actual nest structure. You can see the lip of it right here, and this is the egg clutch. This is found in what's called Egg Mountain, west of Great Falls, Montana, where I used to live. And by the way, Egg Mountain is only about 10 meters tall. Kind of an exaggeration. So it all adds up to an unusual environment, a catastrophe. So how would we explain these features early in the flood? Well, I've developed a hypothesis. It's just at a hypothesis stage. A hypothesis is just an idea. A theory is a well-established hypothesis. Anyway, it's called the beds hypothesis, briefly exposed diluvial sediments. Diluvial is another name for the Genesis flood. So why would there be beds early in the flood, briefly exposed diluvial sediments? Well, it's because the flood level, I put sea level in quotes, would oscillate during the flood. So a local drop in the flood level can expose sediments over a huge area, maybe 200 kilometers wide. And then a rise can cover up and put mud or sand over the features made on those flat bedding sediments, preserving them to this day. That's one of the big issues of all these things. You've got to preserve tracks, for instance, to this day. Well, tracks would normally decay in probably a matter of days to weeks. So here's how it works. Here's a block diagram. This is just one thin block. You got to think of this as going maybe a couple hundred kilometers in all directions. Anyway, we have an area of rapid sedimentation. Here's the top of the sediments, top of the floodwater, and you're having all kinds of deposition. Time 1. At time 2, you form another layer right in here. And then time 3, you do it some more. But finally, the top of the sediments is getting close to the top of the floodwaters, which brings up the possibility that a local drop in sea level can expose the top. Remember, this is over maybe hundreds of kilometers. So you have a flat bedding plane exposed there. So dinosaurs swimming nearby, or maybe from higher land, not yet flooded, can come down on beds. These bedding planes make tracks, lay eggs, eat other dinosaurs. And then at time T5, a rise covers up all those features and lays a layer of sediment on top. So this can explain early in the flood, well, this is all in the general rise of the floodwaters, by the way. So in the general rise, it's oscillating as it's rising, you see. That's the big picture of it. So why would the flood levels oscillate, the surface of the floodwaters? Well, there's at least 5 mechanisms. Now, someone gave me a sixth one time. But anyway, you can have what's called tectonic uplift or subsidence, you know. You have a bedding plane there, it's under the water, and the area is uplifting. So it's above sea level for a while. That's possible. Tsunamis, which would be very erosive at the edge of beds, but once they discharge their energy near the edge, they can just slow down and cover up. But as a tsunami approaches, the sea level will drop, and then it'll cover up the sediments that were exposed during that drop. Lunar tides, of course, and then crustal shifts far away. For instance, a quarter of the way around the world, you have crustal shifts, and if these are underwater, it'll send a wave for a long distance. So as the wave's approaching, the water will drop. As it comes up, it'll cover the area. Also, flood current dynamics, which is rather an involved topic. I won't say too much about it. But this is just kind of a schematic of what to expect at one location for a 7-day period in the flood. This is just a schematic to give you an idea of these flood oscillations. And this is, like I said, relative sea level. I should say relative flood level. So this is you got an uplift. This is tectonics nearby, right at the location where it goes up, and then maybe it goes down, and maybe it goes up, and then it goes down and up. Maybe in a week period you have just 2 uplifts and a sinking. Remember, this is just a schematic. You have lots of different time and space scales involved in this. Here's oscillations due to tsunamis. Now, in the flood, you're going to have a lot of tsunamis because you have a lot of movements of the crust of the earth, and even a slight shift will cause a tsunami when it's mostly underwater. So you can have large tsunamis, little tsunamis, interfering waves from these tsunamis, and kind of a chaos. So you're going to have a lot of oscillations just due to tsunamis. And here's your oscillations from lunar tides. Remember, from day 70 to day 77 in this schematic, you have a general rise. And in that general rise, you're going to get 2 oscillations a day, up and down. And then oscillations from far tectonics. This can cause a slow rise and slow falls from distance. So this is all general. This is not meant to mean anything specific, just to give you an idea of the possibilities for the oscillations in sea level. And this would be from far tectonics, a quarter of the way around the world oscillating, causing up and down motions of the top of the floodwaters. And then current dynamics is pretty involved. As currents are moving across the flooded continents, they usually form waves, sort of like the jet stream in the atmosphere. And when you have a feature like this, called a trough, this is a horizontal, you'll find that sea level can drop in that trough and raise up in the ridges. The atmosphere works sort of like this too. So actually you can intersect the bottom, and these waves would move slow. They can be very slow moving features in the flood currents. And this I had to stretch from 40 to 150 days to give you an idea, because they move slow. And here's that 1 week, day 70 to day 77, approximately. So you have a general rise, but because of these oscillations in current dynamics, you have these big features like this, superimposed on a general rise. So anyway, here's the idea. This is from John Baumgartner and John Barnett from the International Conference on Creationism in 1994. This is a large continent in the northern hemisphere, and same in the southern hemisphere. Your main currents were going like this, and they intersected the bottom in the center of this trough, as you would call it, and they rise up. It rises up in here. So this can stay dry sediments, briefly exposed sediments, for weeks possibly. So that's another feature that can cause oscillations in flood level at many time and space scales. That's the point of all this. And this is sort of a summary diagram drawn wrong. This is your 1 week period again, and you have lots of oscillations, and within those oscillations you have little oscillations. What I do need on here is intermediate size oscillations between these and these. That's what you really should expect. In other words, lots of oscillations, probably maybe hundreds of oscillations in the flood level. And here's a few schematics that kind of show you how it works. Now, this is the oscillations due to a tsunami. So this is the first one right here. Sea level, first of all, falls, and they're making tracks on beds right in here, and then suddenly this is coming up on them and overwhelms them, but slows up as it's spreading out over here, and so it'll really erode the edge, but then after a while the energy will be partly or mostly dissipated, and then it'll just simply cover up dinosaurs, tracks, and eggs like that, and then it'll recede and probably cause another fall. These are just schematics. You got to think of these areas as maybe over a couple thousand kilometers. This area here. Here's another one, the sea level falls. You know, they're making tracks, laying eggs. And then sea level rises. Often they'd probably drive them totally off of the land area, but we'll say they can hold on. But it lays a layer of sediment over the features already there, dead dinosaurs, maybe scavenged, eggs, tracks, and then fall. And they can do it again. So you can have multiple levels by these oscillations. So here's a general area of briefly exposed diluvial sediments. This is just, you have a lot of dinosaur features in here. These megatrack sites, you have millions of them around Moab, Utah, in a strip right in here around Paluxy River, and actually around Shell. There's one there, and you have tracks, eggs, all through here. So this would be a great area to expose the sediments several times, or numerous times, and form these features early in the flood. Now, there's also a number of associated features with dinosaur tracks. Mud cracks, I put these in quotes because it's not certain that these are really mud cracks, because you can actually form what looks like mud cracks under the water. So raindrop imprints, bird tracks, coprolites, paleosols, burrows, social insect nests, if they're, like I said, if they really are. These features are sometimes claimed to be associated with dinosaur tracks. For instance, here is the bottom of mud cracks right in here, and here's a dinosaur track, the bottom of a dinosaur track, together. Okay. Thanks for telling me, because I can't see how fast I'm going or slow. Bird tracks. So I believe they occurred after the heavy rain, because the heavy rain would wash them out, but before day 150. So in summary, dinosaur tracks, eggs, and scavenged bone beds occur early in the flood. They can be explained by the beds hypothesis. Sea level or flood level falls to expose beds and rises to cover up dinosaur features. Beds explains associated features and indicates dinosaur features formed from day 40 to day 120. There's all reasons for this day 120 I haven't got into. All these dinosaur features are worldwide, indicating a global flood. This supports the Genesis flood and the whole Bible as God's Word. So if you want to know more about it, it's written up in this book, Dinosaur Challenges and Mysteries. And this is a book that I edited with John Reed about 12 other mysteries. This is an in-depth book, by the way. And of course, I told you about the children's book. And if you want to, one place we publish a lot of this information is in Creation Magazine. Goes out to 110 countries, full color, so forth. Anyway, thank you. I'm out of time and went over.